So today, or this week, we're going to be working on transforming the sine and cosine functions, specifically looking at their graphs and using the numbers in the equation to vertically and horizontally compress, stretch, flip, and shift the function. Today we're going to focus on the vertical transformations. They tend to be a little bit easier. And so we'll start with that, and then we'll work to the more complicated horizontal actions that will affect our sine and cosine functions. So our essential questions are, how do I use a, that's going to be a constant in our function, a number in our equation, and d, to vertically transform the sine and cosine functions. What we're going to do here is just start by graphing the basic parent functions for the sine of x and the cosine of x. And all I'm going to do is use my unit circle that I've drawn here. And I'm just going to graph the quadrantal points. So we're talking about the points that are on the unit circle that are on an x-axis or a y-axis. So we're going to start by doing the sine function. So I'm going to do sine of x, or f of x equals sine of x in red. Okay, and you can see over here on my unit circle that I've already color-coded my sine function values. So the sine of 0 radians is 0. The sine of pi over 2 is 1. The sine of pi is 0. The sine of 3 pi over 2 is negative 1. And the sine of 2 pi, we're back at 0. Okay, I can also rotate in this manner. So if I go sine of negative pi over 2, that's negative 1. Sine of negative pi is 0. Sine of negative 3 pi over 2 is positive 1. Sine of negative 2 pi is 0. So here we're just going to attempt to sketch our curve here without the pi over 4s. We're just going to graph our peaks and valleys and our zeros. All right. And so here we have our sine function. So I'm going to label that as our sine of x. Okay, and let's take a look at it. It's got a period of 2 pi, and that's because every time you go around the unit circle completely from 0 to 2 pi, you'll hit all of the points and then you start over. And so it cycles through the same set of points every rotation of the unit circle. So every 2 pi radians you recycle through the set of points. All right, it also has an amplitude, in this case of 1. And the amplitude, if you remember, comes from the distance from the midline to the peak. So the midline would be right there where the zeros are, right? Because your minimum is at negative 1 and your maximum here is at positive 1, and so it's half the that's a distance of 2 units. If you go from there to there, that's a distance of 2 units. Well, the amplitude is half of that distance, or we could consider it the distance between the midline, which is 0 is halfway between negative 1 and 1, to the peak or the valley, and so it has an amplitude of 1. All right, so there's our sine function. Now let's go ahead and do our cosine function. So I'm going to switch to my blue pen here. So we're going to do our cosine function in blue. And now I'm just going to cycle through all of the points here in blue. So at 0 radians, the cosine of 0 is 1. Cosine of pi over 2 is 0. Cosine of pi is negative 1. Cosine of 3 pi over 2 is 0. And the cosine of 2 pi, we're back at 1. And if we were to rotate in a negative manner, we would go negative pi over 2 is 0. Negative pi is negative 1. Negative 3 pi over 2 is 0. And negative 2 pi is back to positive 1. So here we have our cosine function, and I'm going to attempt to draw that curve here. There we go. And so there's our g of x, or our cosine of x. And let's take a look at that as well. If you can look at the period of the cosine function, every time we cycled around from 0 to 2 pi or 0 to negative 2 pi, every time you do a full rotation, you go from maximum point to maximum point, and then you start over again. So it also has a period of 2 pi, and it also has an amplitude of 1 because it maxes out at positive 1 and minimizes at negative 1. So half of the distance between those two, right? That's a distance of 2 between the minimum and the maximum. Half the distance is 1. So it has an amplitude of 1. So those are the two functions that we're going to work transforming all week. We're not going to transform tangent, cotangent, secant, cosecant. We're just going to work on these. So we are going to do some variations on the basic graphs, and I'm going to define them all today, but we're going to focus on A and D today. All right. So when we add in numbers, the constants A, B, C, and D, and that shouldn't be capitalized, we can transform the parent functions accordingly. So we have y equals A times sine of bx minus c plus d, rewritten as, I tend to like to rewrite it because I really like to factor that b term out. So if I were to take bx minus c and factor out the b, basically what I'm doing is dividing both of those values by b. So I would write it as b times x minus c divided by b. And we're going to do that. You're going to find out tomorrow why that's so useful. So we're going to rewrite this as y equals a times the sine, and I'm going to use a bracket here, of b times the quantity x minus c over b, close the quantity, plus d. Same thing for our cosine function here. I really do prefer this form of this equation that is written in transformational form. Now, hopefully you're looking at it going, okay, so I recognize that. Like if I were to give you something like y equals a times x minus, maybe b, let me do a bx minus c quantity squared plus d, that would be giving you a quadratic in transformational form or vertex form. And the a, b, c, and d basically do the same thing, regardless of what kind of function we're working on. All right, so let's just define what a does. So I'm going to just start with my black pen here. So a is outside the parentheses, if you notice. So that means it's a vertical action. Okay, and if a is greater than the absolute value of what? Excuse me. Oh, I'm sorry, guys. Okay, if it's greater than 1, it's going to vertically stretch your graph. If a is less than the absolute value of 1, meaning it's a fraction, it's going to vertically compress. Okay, so remember, if you're stretching it, you're taking your y-coordinate, you're doing a times your y-coordinate. If you're compressing it, you're doing your y-coordinate divided by a, or multiplying it by a. You can always just multiply your y value times a, and that'll stretch or compress it. Okay, if it's a negative a, then it's a reflection. It's a vertical reflection. So you're going to go across the x-axis from top to bottom and bottom to top. And here's something else that's really useful, that's specific to the sine and cosine functions. The absolute value of a is the amplitude of the function. So you don't even need the graph in order to identify the amplitude. A is the amplitude. So that number right there will tell you what the amplitude is. All right, we're going to move on to B. I'm going to do this in B. Now B is inside the parentheses with the x, so you know that's a horizontal action. Okay, so I'm going to look at it in this form over here, this B that I've factored out. B is horizontal. And if b is greater than the absolute value of 1, remember that everything inside the parentheses is opposite. That's going to be a compression. So you're going to take your x coordinates and divide them by your absolute value of b. Actually, no, because if it's negative, then that'll do the flip. So that'll be okay. If b is less than the absolute value of 1, that's going to be a stretch. So you're going to take b and multiply it times your x to stretch the points horizontally. If it's negative b, it's going to reflect horizontally. So it'll go from the left to the right and the right to the left. Now, what else that's nice to know about b is b helps you to define the period of the function. So since we're dealing with the cosine and sine functions, they both have a period of 2 pi. So if I divide 2 pi by the absolute value of b, that's just a little formula that helps you to identify one full cycle of the cosine wave or the sine wave. It tells you how long is the period before the little wave repeats the same set of points. All right, moving on to the c over b, and I'm looking at this over here. This is also inside the parentheses, so it's horizontal, and it's your horizontal shift. So I'm going to write that as a horizontal shift. Now remember, when you're in the parentheses, everything's opposite. So if it's minus c over b, you're going to go right c over b. If it's plus c over b, you're going to go left c over b, right? So that's right, left. Everything opposite, shifting opposite. All right, also something that's really useful to know is what is called the phase shift. We call these phase shifts when we're talking about the unit circle and we're talking about circular motion, sine and cosine wave. What it does is when you're talking about a phase shift, what happens is you'll take something like a point on the unit circle here at 0, 0, and if there's a phase shift of negative pi over 2, this point will shift back to here and everything will rotate with it. And so that's what we call a phase shift. All right, so the phase shift is the opposite of c over b. So if your phase shift is pi over 2, then all of your points are going to shift left pi over 2. So whatever was at 0 will shift back to negative pi over 2. Whatever was at pi over 2 will shift back to 0. Whatever was at pi will shift back to pi over 2, like that. So we're just shifting all of those points. All right, and then D, I'll do this one in red here. D, outside the parentheses, is vertical action, So if it's up D, plus D, you're going to shift up D. And this is definitely a vertical shift, so let me go and write that down. It's a vertical shift. If it says minus D, you're going to go down D. And something else that's particular to the sine and cosine functions is the midline will be the equation y equals D. And this is all specific. All of this information is specific to the sine and cosine function. So if you wanted to put that on an index card so that you had that information available, it gives you all the formulas that you could use to help you identify all of those critical pieces of your sine and cosine function. All right, so let's take a look at example 1. It says sketch the graph of y equals sine of x plus 3. Notice that plus 3 is not in the parentheses with the x, and so it's not a horizontal action, right? So that's the D term right there. It's a plus a number, right? So that's a shift, and since it's not in the parentheses with an x, with the x, it's a vertical shift, so you're going to push everything up 3. Label the midline, identify the range. So the first thing I'm going to do is just graph the sine function. So I'm just going to graph the parent function. So I'm going to grab my gray pen. So the sine of 0 is 0, the sine of pi over 2 is 1, the sine of pi is 0, the sine of 3 pi over 2 is negative 1, the sine of 2 pi is 0. And then I'm just going to duplicate those points over here. And I'm just going to draw a sketch of the sine function, right? So that's just my parent function, y equals sine of x. And what I'm going to now do is take all of the points for sine of x and push them up 3. Now remember that I also told you that the midline is y equals d. So this case, our midline would be y equals 3. So I'm going to go ahead and graph that line, and then I'm going to go back with my eraser and make it not part of my graph, just a helpful tool to help me graph my points, right? And I'm going to just take all of my y coordinates and push them up 3. So this is y here, this is y equals 0, so I'm going to push that up to y equals 3. This is y equals 1. I'm going to push that up to y equals 4. This is y equals 0. Push it up to y equals 3. Y equals -1. Up 3 would be 2. 0 to 3. 1 to 4. 0 to 3. -1 to 2. 0 to 3. And here we have taken all of the points on our parent function for our sine function. And we have y equals the sine of x. And all we did with all of those sine of x points was we added 3 to them. And we were adding them to the y value because that's vertical. All right, our midline, we're supposed to label our midline. So for B, that's A. A was to graph, so that's the answer to A. B, the midline is y equals 3 because it's y equals D. And the range, C, what is the range? The minimum, that's -2, so that's +2, to the maximum point, which is at 4. And so there is the range of your new function. Whereas on your original function, your range was from -1 to 1. And your midline was at x equals 0 because it was +0, no D. Right? Okay. And so that's using a vertical transformation on your sine function. Let's try example 2. Now with example 2, I'm going to do the first part, and then I'm going to have you do, I'm going to do the first example, A, B, and C. I'm going to have you do D, E, and F, and then we'll see how you did. Okay, so with this one, with this set, we are doing cosine x. So we're going to start with the parent function of the cosine of x. And so cosine of x. Now let me see. I'm supposed to do this function here in red. So I'm going to do this in red. Y equals, so I guess I'll just use my gray pen again to identify the cosine function. So the cosine of 0 is 1. Let me get pencil here. 1. Cosine of pi over 2 is 0. Pi is -1. 3 pi over 2 is 0. 2 pi is 1. And reversing. And you guys are going to graph so many versions, or so many cosine of x and sine of x's, that you'll get these two graphs pretty well memorized. You won't even need your unit circle. All right, so that's y equals cosine of x. Now what I'm going to do is look at my equation. So here's my equation. I'm going to grab my red pen. It says y equals 3 cosine of x. So 3 is in the position that the A would be, right? So that just means that I'm going to take all of my points, right? So we have x, and then we have cosine of x, and then what we're doing is we're multiplying that times 3, right? So I'm going to do 3 times the cosine of x. So I'm going to go grab my points from my original. So at 0, I was at 1, and at pi over 2, I was at 0, and at pi, I was at -1, and then at 3 pi over 2, was back at 0, and then at 2 pi, I was back at 1. And all I'm going to do is multiply all of those values on my y, because remember, this is a vertical action here, so I'm changing my y times 3, times 3. So if I'm looking at this analytically, this is what I'd be doing. So this would be 3, 0, -3, 0, and 3. So I'm basically going to just stretch all my maximums and my minimums. So I'm going to max 0, 3, pi over 2, 0, pi -3, 3 pi over 2, 0, and 2 pi is 3. So you can definitely see that amplitude change, right? Look at how vertically stretched those points became. And we'll go ahead and do that on the other side, just using our brain here. And I'm still going to hit all those zeros, but look at that amplitude change. All right, and so that's A. That's our answer for A. What is the amplitude? Now, the midline hasn't changed because our midline is plus 0, right? So we're just looking at the distance from 0 to the peak, right? So it has an amplitude. And P.S., amplitude is just the absolute value of A, so it's the absolute value of 3, which is 3. So at this point, you could almost just get away from even thinking about the amplitude. Just go, amplitude's the absolute value of A, so it's 3. What is the range? We're looking at that from the minimum point to the maximum point on your Y. So that's from -3 to 3. Okay, so you guys give D a try. D, E, and F, and let's see how you do. I will just have you pay attention to the fact that this is a -1/2. So your A is -1/2. So that means, the negative means that you have a vertical reflection and a compression, right? Because it's 1/2. So you're going to compress all your points and flip them. Give it a go, and let's see how you do. All right, so hopefully you gave that a go and you were able to come up with this blue graph that I have here. You can see that because my A was negative, that my wave flipped upside down. And basically what I did was I took all of my minimum and maximum points and I just multiplied their Y value times -1/2. So here I did +1 times -1/2 is -1/2. 0 times -1/2 is 0. -1 times -1/2 is +1/2. And like that. And so there is your Y equals -1/2 cosine of X. Right, amplitude is the absolute value of -1/2 or 1/2. And the range was from -1/2 to 1/2. All right, so last one here of graphing. Here we're taking and we're going to, let's look at this, let's take apart this equation here. We have Y equals, we have the sine of X, all right, but we have 2 sine of X minus 1/2. Now, none of those values were inside the parentheses, so this is our A and this is our D. Okay, so what is our A telling us to do? Our A is telling us that since it's greater than the absolute value of 1, because it's 2 is greater than 1, it's going to stretch vertically. And then the D is -1/2, so we're going to push all our points down 1/2. Okay, so that's what we're going to do. So we're going to take our sine function. All right, so I'm just going to graph that real quick, parent function. Learn it, memorize it, know it. And then we're going to stretch all of these points. We're going to stretch them vertically by a factor of 2. All right, so I think I'll do this in an intermediate step here. So I'm going to do this vertical stretch in green, and then I'll do the shift down 1/2 in blue. All right, so I'm going to vertically stretch. 0 times 2 is 0. 1 times 2 is 2. 0 times 2 is 0. -1 times 2 is -2. 0 times 2, 1 times 2, 0 times 2, -1 times 2, 0 times 2. All right, so I'm not going to make a solid graph here because this is just my first step. Okay, so I'm actually just going to label this over here as Y equals 2 sine X. So that's my first transformation, and then I'm just going to take my blue pen and I'm going to shift all of those points down 1/2. So I'm going to take all of my Y's and subtract, because it's a vertical action, so you take your Y coordinates and push them down 1/2. So here I'm at Y equals 0, down 1/2 is -1/2. Here I am at 2, down 1/2 is 1.5, 0, down 1/2. Down here, -2, down 1/2, 0, down 1/2, 2, down 1/2, 0, down 1/2, -2, down 1/2, and then 0 down a half. And that, I'm going to do my solid graph. So this is going to be my final graph here. Now, a lot of you probably are already at the point where you could do both of those transformations at the same time, like just stretch everything out by 2 and then everything down in a half. Now, let's take a look at what I actually should ask the question, and I'm going to add the question D. What's the midline? All right. So here our midline is our D, right? So y equals negative 1/2. So I'm actually going to put that in, y equals negative 1/2. There's our midline. Right there, right? So we've got an amplitude is the absolute value of 2. So it's got an amplitude of 2. And its range is its lowest point, which is down here at negative 2.5, to its highest point up here at 1.5. So the range is from negative 2.5 up to 1.5. And there you go. All right, so that was just a double vertical transformation there. Now let's see if we can work from descriptions and write matching equations. So example 4 says, use y equals cosine of x to write the equations of the following. So we're going to write the equation of y equals cosine of x as a reflection across the y-axis. So if we're going to reflect across, this should say the x-axis, so let's change that to the x-axis. And this also across the x-axis. All right, so use y equals cosine x to write the equations of the following. A reflection across the x-axis, that just means if I have a point up here, that I'm going to reflect it down here, and if I have a point down here, I'm going to reflect it up here, right? So that's a vertical reflection. So that means that A is negative. It must be negative. So you take your y value, multiply it times a negative, and that'll flip it over the x-axis. So that would be y equals a negative 1 cosine x in this case, or simplified y equals the negative cosine of x. Let's look at B, a reflection across the x-axis. So that means A is a negative, and an amplitude of 4. So that means that A equals negative 4 because it's got the vertical flip and the amplitude or the vertical stretch. So that would be y equals negative 4 times the cosine of x. In this last one, we have an amplitude of 1/2 and a midline of negative 2. Y equals negative 2. So your A is 1/2 and your D is your midline, negative 2. So y equals 1/2 of cosine x minus 2. And that's just how you would write the equations. And that's it. So you've got some practice to do on Canvas. Write a quick summary of all that you learned. And I will see you guys